with a friend? No way!
Cruising on down Main Street, you're relaxed and feeling good. Next thing that you know,
It is you. Hey, I didn't see y'all there. How y'all doing? My name is Darian White, and I'm in the 2 p.m. Physics 2 class with Dr. Storr. And what's this right
Hey,
here?
it's me, Deja Jones. I stood next to him in class.
And today, we will bring you guys a project on resistors and circuits. For this experiment, we will be using the following materials. 1 Edison plug with a ground. 1 set of cables with 3 conductors on the inside. Multiple bulb sockets and or holders used to hold the bulbs and wire them to each other. A switch to open and close our circuit. And then a few other items for just good housekeeping, if you will. We have our bulbs, which are rated at 60 watts. And our connectors to, once again, clean everything up and keep everything nice and neat. So here we have our circuit for 1 bulb in series. Right here will resemble our 120 volt power supply or battery, whichever way you would like to. Those are our leads. This is the switch wired within the circuit. This is the bulb holder that's also wired in series that will hold our bulb. And now, once we flip this guy over and dig into our good old box of bulbs, give him a nice little righties tighties. And our circuit is just about complete. So now, once we add some power to our circuit, and we flip the switch, you can see we have light, which resembles current flowing through the resistor. Now let's show you the calculations behind this.
What we're going to do now is our calculation for 1 volt in series. So I'm going to draw out the circuit. Okay, so the bulb is 60 watts and our voltage is 120 volts. So we're going to solve for the resistance. So what we have is power equals 60 watts. Our voltage equals 120 volts. And we're trying to solve for our resistance. So to solve for our resistance, the equation is R equals
R equals
V over I. R equals V over I. But we don't have our current. So we're going to also have to solve for current. And the equation that we'll use is power equals current times the voltage. If we're going to solve for the current, then it's going to be I equals P over V. So if we plug in our numbers, we'll have 60 watts over 120 volts. And if we calculate that all out, we'll get 1 over 2 or 0.5. What's the amps? Yeah, amps. So now that we have our current, we can plug our current into the resistance equation. So we'll do resistance equals 120 volts over 0.5 amps. And our answer will be 240 ohms for our resistance. So we can go back, and resistance equals 240 ohms.
And so for this part of the experiment, we have 3 bulbs wired in series. As you can see, we have our switch, we have our first 2 bulbs, and we will add our last one. Now, let's pause this video right here, people and peopleettes. I remember from the wise words of this man named Dr. Storr. I think I met him in England or somewhere, I don't know. But he always taught us that if you have resistors in series, you add them together. And if you knew that part, guess what? You know how to solve everything else. So if you have resistors in series, you add them together. If you have resistors in parallel, you take the inverse of each resistor and then you add them together and you take the inverse of your sum. So hold on to that. You might need that for the final. Back to our circuit. We have our last bulb that we will use to complete our circuit. And yeah, he wanted to take a tumble. But once we get him back into the slot and we complete our circuit, and once we flip our switch and send our 120, we have power through all of our bulbs. But as you can see, they look slightly dimmer than that of the previous video. Why is that? Don't worry, we'll explain it to you. So Dr. Storr, I'm pretty sure you're probably wondering, like, that's just 2 or 3 60-watt bulbs. That's not a lot of resistance on a circuit. Say no more, Dr. Storr. I got you covered. So if we were to present to you 2 500-watt bulbs, I know that's a lot of power, you know. Probably might be bright enough to light up your Cowboys to a victory one day. We never know. But you have 2 500-watt lamps wired in parallel. And so let's see how this works, right? We're going to plug it in and connect it in our circuit. The box is going to allow us to connect it in parallel. We've tied into the box already with our live and our neutral. We have our switch in the circuit. And let's get everything wired up, shall we? Ladies, if you're ever worried about having enough lighting for your filter and your cameras, you just need one of these bad boys in your room and you'll be straight. So, without further ado, once we add our 120 volts to our circuit, it's hard to do when you're doing it with one hand and you're recording with the other hand, but you know, bear with me. Cool. So once you get it plugged in, you get everything wired up and you flip your switch, you now have 2 500-watt bulbs on one circuit. Keep in mind that a regular household circuit can only hold 15 amps. So let's calculate how much these 2 500-watt bulbs in parallel are pulling on this circuit. We have our circuit for 2 bulbs in parallel. So let's start with our 120 volt power supply, right? And then we come here, we have our first resistor, which is our bulb, and it's 500 watts. Resistance is, we don't know. Then we come over here. I'm such an artist, y'all.
Picasso.
Another one. We have another one as far as on our resistor. Also, once again, this one is unknown. So, writing our givens out, we have power 1, power, oh wow, sorry, my P's and my R's today. Power 2, and they're both 500 watts. 500 watts. Then we have our voltage, which is 120 volts. And we're going to try to find our resistance for 1 and 2 and our equation is resistance. First of all, to get your total resistance, it's going to be, since they're parallel, it's going to be 1 over R1 plus 1 over R2 equals 1 over R equivalent. And then for resistance for each one is RO is equals, wow, R equals V over I, but we don't have an I. So the only other equation that we have that could use that is our power. So our power is I times V. When we manipulate it, you get I equals P over V. So once we start plugging in our numbers, we have 500 watts over 120 volts. And not everybody's as cold as Dr. Storr to
He be coming off the dome.
off the dome, y'all. So 500 divided by 120 equals 4.1666667 amps. So once you take that, now you can plug that in to your equation up here to get your resistance for each bulb. And so now you do R equals 120 divided by 4.166 equals 28.7997. So once you round it up, it'll be 28.8 ohms. So then once you come back over here, now we know our resistance for each bulb, which is 28. So once we have our resistance for each bulb, 28.8 ohms and 28.8 ohms, then we can come over and solve for our total resistance, which is going to be 1 over 28.8 ohms plus